Good morning, everyone. Let's tell you what we're going to get done today. We're going to finish 15.4 in applications. Basically, the homework from 15.4 involves finding mass and center of mass of a lamina, which is basically just a disc of some kind, or a rectangle, a piece of metal, which indeterminate thickness, and a couple of questions at the end, which are about calculating the total charge using a density function sigma. So if you want to get the mass, you just do a double integral of the density function. So we know how to do double integrals. It could be a rectangle, it could be a non-rectangular, or it could be some kind of circular object. And depends on what we get, how we do this double integral, right? Now, what about the center of mass? Well, can you imagine that I've got a triangle? But that triangle has different densities. At some points, it's really dense. At other points, it's quite light, and maybe dense here and then kind of goes light again. Right, so it's got different density amongst it. So it has a density function, xy. The center of mass, called x bar, y bar, is a point typically on the disk, the lamina. Let's say it's about here. And that point, x bar, y bar, is essentially, how do you describe it? It's like a balance point for the shape. If I had this triangular piece physically in front of me, and I stuck a pen exactly there, this shape would balance. It would stay there, right? If you could do it perfectly, right? Have you ever seen people in circus performers who balance some weird objects like chairs? If you ever notice it, don't they bend the chair in a particular angle along one leg? And what they're doing there is they're making sure that the center of mass is vertically above where they're holding it. And that way you can balance it. So how do you get it? Well, the x coordinate of the center of mass is 1 over the mass, the double integral of x times the density. And y bar, the y coordinate of the center of mass, is 1 over the mass, the double integral of y times the density function. It's got a kind of simple beauty about it, doesn't it? It's not a weird x squareds and weird stuff like that. It's a pretty tidy little thing. So obviously, to get the center of mass, we need to get mass. So basically, these two questions belong together. I read these two things. So let's pick an example. That's too late. Let's pick something earlier. Right, this is a question 3. Or at least like it. The region D that we are going to work with is y equals 0, y equals 4x, and x add 4y equals 1. And the density function this time is equal to x. Sometimes the density function has a k next to it, like we did yesterday. It's kx. Sometimes the density function is described as proportional to the distance from the center. In this case, the density function would be the square root of x squared plus y squared. But in this case, it's given. So what I would do first in a question like this, if I'm not sure what it looks like, I'd use Desmos, but I think I should be able to draw this thing. Y equals 0 is basically the x-axis. Y equals 4x is a straight line that looks something like this. And x plus 4y is a straight line that is there and is there, and it goes like that. And so the region we're interested in is this triangle here. And I'm going to call this guy x plus 4y equals 1. Now, I'm going to calculate the mass in a few moments. And the mass is just a double integral over this region D of our density function. Yeah. Now we have to make some decisions. This is non-rectangular. So I'm not going to do x equals 1 to 2, y equals 2 to 4, right? It's not rectangular, right? It's clearly diagonal. And it's not polar. So you know that's the guy in the middle, right? Now, when you do a shape like this, we have to describe what D is in terms of x and y. And we have a decision to make. Are we going to do it horizontally or are we going to do it vertically? And in some situations, both are equally good, so it doesn't matter. But in many situations, it does matter. And I am going to go horizontal, which means y is going to go from 0 to 1/4. Why did I decide to go horizontal rather than the other? I only have two choices than going vertical. Why did I go horizontal instead of vertical?
So you could do it in one integral instead of splitting it into two.
Yeah. Now, since I'm going to go horizontal, these two equations are really not what I want. Don't I want these two equations to be x equals a function of y? Because over here, it's going to be the bounds of x. This one is going to be one of the straight lines, and this is going to be the second. So a quick bit of surgery. This is the same thing as x equals 1/4 y. A little bit more work on this one, but not, I guess, that much when I think about it. Are you happy about converting to an equivalent form? Now, I have one last decision to make as far as creating D is concerned. But you need the guy here, and you need the other guy here. One of these goes to the right, and the other one goes to the left. Which one goes on the right-hand side?
Professor, I have a quick question.
Yes.
Before that, where did you find the upper limit for the y coordinate?
Oh God, it's not a 1/4.
Yeah.
It needs to be there. Thank you.
Exactly. So.
Let's find that point. How will I find the coordinates of that? I'd probably put it in a Desmos and look at it, right? You know, just click on it. But since I don't want to go through the Desmos stuff. It basically then don't have to solve a system of equations. But if y is 4x, can't I just say x plus 4 lots of 4x is 1? So 17x is 1. What a ridiculously ugly value. And that makes y 4 times that. Ugh. Well, well caught, G. I never realized I did that. Right, back to this one. Which one of these two guys' equations belongs in the right-hand side? You have a 50-50 chance, I guess, but I'd rather you didn't guess.
One minus 4y.
And because it's the one that's furthest to the right.
Yeah.
Correct.
And then once you got that one, you just stick the other one in, don't you? I know it's right, but I don't like these numbers. They're just awkward fractions. WebAssign is normally better than this, right? They normally give you questions with halves and twos in them, but it is what it is. Okay, so let's get the mass then. It's going to be from y equals 0 to 14/17 is going to be x equals 1/4 y to x equals 1 minus 4y. The density function was just x, and we're going to do a dx first, followed by a dy. Does that look good? Okay, let's move on. It's going to be 0 to 4/17, 1/2 x squared, evaluated at 1/4 y to 1 minus 4y. It's going to be 1/2, 1 take away 4y squared, subtract 1/2, 1/4 y squared dy. I am really not liking this question. I'm going to do a cheat here.
I can't do that.
Oh God, it is a yikes. Oh, yikes. Okay, can you just trust me that this horrible mess eventually becomes 12/289? Not only did I not like the answer, it's also correct. Yeah, I tend to get worried when things go really ugly. It just doesn't feel right, but actually in this case, it is really ugly. So that's just the mass. We haven't yet calculated the center of mass. So here goes. X bar is the double integral over d, 1 over the mass. The double integral over d of x, density function, dE. But the mass is this guy. So if you turn them upside down, you get 289/12. The limits of integration are the same limits all the way through. So it's 0 to 4/17, and it's 1/4 to 1 minus 4y. And won't this be x times another x? So this is going to be x squared dx dy. And this is going to be 1/3 x cubed, evaluated at these endpoints. And this is going to be 1/3 1 minus 4y cubed, take away 1/3 1/4 y cubed dy. And I'm going to cheat again. Oh, well, you're just going to have to trust me on this one, but that's the answer eventually. I mean, the process is not that difficult. I mean, finding the integral of x squared dx is not a hard thing. Isn't the hard thing just the downright ugly bits that you're plugging into it? You're just going to have really weird fractions being cubed and added to other weird fractions. But that is x bar. Now, if you wanted to get y bar, it would be 1 over the mass, the double integral over the same region d, but this time it would be y, the density function. And turn it upside down, you get 289/12 from y equals 0 to here, from this fella to that fella, and it would be xy that you would do. And I'm not even going to go through that one, or we'll be here all day just on one question. And you'll just have to trust me that this one ends up being 19,306. So the center of mass is about a half. That's roughly a half. And this guy is very roughly 22, 1/15. So it's like a half comma a 15th. So the center of mass of this fella is about 1/2, 1/15. So I'm guessing somewhere in that region where they put the dot. A little bit unsatisfying, that one, just because of its ugliness, not because of the question. Let's see if I can do another one that's just nicer numbers. This time I've got the solutions on it, but I can tell you right now, question 4 is nice on one side and really ugly on the other. Oh, this one's okay. Same question, find the mass and the center of mass for a disk D, which is x squared plus y squared less than or equal to 25. And the density function is proportional to its distance from the origin. So proportional distance from the origin. So this one has a K in it. The region D is very nice, except I should have paid attention that it's only in the first quadrant. Have we done that guy yet? Looks familiar, but we've done lots of. Would you agree this one's going to be polar?
Is that an R or a K in front of the square root?
In front of the square root?
Yes.
It's a K. Yeah. I don't know why it's a K. So in the first quadrant, that's the guy. That makes D in polar form. That the R goes from 0 to 5. And that the theta goes from 0 to pi upon 2. Are we all comfortable about quarter circles and our polar description? So the mass is going to be the double integral over D of the density function, dA. In this case, that's the density function. What will that look like if you convert this into polar?
RK?
Yeah, K times R times K, that guy. So it's going to be from R equals 0 to 5, from theta equals 0 to pi upon 2, the density function, another R, dr, d theta. I almost forgot it. When you do polar, don't you get an R as well as a dr d theta? Easy to forget. So it's now going to be the integral from theta equals 0 to pi upon 2, R equals 0 to 5 of K R squared dr d theta. Are we good? So far, so good. So let's take it. Is this one separable? Can we separate this thing? Okay,
Yes.
so let's do it. From 0 to pi upon 2 of, I don't know, I'll give it the K. Why don't we give it the K? And from 0 to 5 of the R squared. If you do this guy, you will end up with K pi over 2. This guy will get you 1/3 R cubed, which will get you 125 over 3. And so we have 125 k pi over 6. And there's your mass. Anybody disagree with that? Does it look good? Okay. Right, this is, I know that's maybe not the perfect answer, but it's nice. I'm just going to write the mass down so I can move that piece of paper out of the way. So I don't have time to do X bar and Y bar, but I do want to do one of them. So which one do you want me to get, the X bar or the Y bar of this question?
Which one will be worse?
They're actually equally hard or equally easy. They're pretty much the same.
Let's do Y bar.
Okay. So it's going to be the double integral, 1 over the mass. Got to remember that. That fella, right? Yeah. I keep writing this down because I know you'll have things written in pieces of paper beside you, but for my brain, if I write the formula down before I actually do the details, it just helps to get it in my head to stay there, so that when I think of Y bar, I'm already thinking of this. I'm not thinking, I'm now going to have to find that piece of paper where I wrote the formula down so I can remember which one to use, especially when you get to the end where there is, I don't know, 30 formula that you could be using and you're not sure which it is. So 1 over that guy turns into that guy. The integration is the same one as it was before. I can find the limits. Here we go. So theta
So for
equals
these
0.
equations, the limits never change. They're always the same.
Yeah.
Okay.
So the d is the same all the time, so the limits are the same all the time.
Okay.
Now the density function here, we already converted that, wasn't it? K r. Did someone notice what I forgot to write down in Y bar? Which I'm glad I just noticed.
The Y?
The Y. Except in polar form, what will Y be replaced by?
Wouldn't that be R sine theta?
Great. So I'm going to have an R sine theta for the Y. That's rho. And I've still got an R dr d theta, right? Because that is him, right? This guy is him. And this fella is him. Do you see the 3 bits and 3 bits? Everything went polar. R cubed. Okay, good. Yeah, I got an R cubed. I'm trying to think of where to put it. There's my sine theta. I'll stick my K at the end. Variable separable? Yeah. So 6 over 125 k pi. The integral from 0 to pi upon 2 k sine theta. And the integral from 0 to 5 of r cubed dr. Okay, you want to integrate this guy, you get negative k cos theta evaluated at 0 to pi upon 2. You want to get this guy, you get 1/4 r to the 4 evaluated at 0 and at 5. Okay, you plug in pi upon 2 here, you'll get 0. You plug in 0, you get negative, you get 1, but 2 negatives make a plus. Bottom line is that ends up being k. This fella is 625 quarters. Let's see if we can make this pretty. That K gets killed off. There's no more Ks. 4 and that guy. Does 125 and 625 cancel? Sure do. What's the best you can do with a 125 and a 625?
5.
It goes down to 5s.
Well, you can do 25s as well. So if you do 25s here, you'll get 4, you'll get 5 of them. And if you do 25s here, you get 25s, and then you cancel and you cancel and you get 5. Just like you said. So what am I left with? I'm left with 15 on the top.
Professor, really quick.
Yes.
Where you have minus k cosine of theta from 0 to pi half, is that supposed to be 0? Isn't cosine of pi over 2 0?
Yes. The cosine of pi upon 2 is 0. Right. This is what I did. I just said it, but let me show you what I did. I did negative the cosine of pi upon 2, take away negative the cosine of 0. The cosine of pi upon 2 is 0.
Okay.
Take away 2 guys, and that's a 1. That's the K that you got.
Got it. Yeah.
Right. Well, I like that answer. Compared to the previous one, isn't that at least decent? There's some interesting fact that came out of that is, did you notice that although the density function had an unknown K in it, the X bar and Y bar will not have that? That is not a coincidence that just happened to work in this question. If you ever have a density function that is K times something, the mass will have K in its answer, but the X bar and the Y bar will not have a K. And the reason for that is, isn't the 1 over mass going to have a K in it, and the other guy will have a K in it, and they'll always cancel 1K for 1K. So X bar and Y bar will never have a K in it. Right? They will just be pure values. But mass will, if the density function has it.
Okay.
Okay. I don't know what X bar is, so let me check. X bar is, I don't know what X bar is. I've lost the question. According to them, and I may be looking at the wrong question because of my scanning issues. It looks like the other guy doesn't even have a pi in it, which is very surprising. This has a pi in it, but the other one didn't. Okay. That just doesn't feel right, but I have to assume that I'm not going to do a 15-minute question just to find out, oh yeah, there isn't a pi in the answer. Wonder how that would be the case. Don't know. Short answer. I don't know why one of them didn't have a pi. Okay, so for the next few moments, we're going to look at the homework questions themselves. And let me get the solutions out of the way because they distract me as well. And we'll just talk through the process that we would be using to get those answers. And then we'll look at the last group of questions, finding the total charge. Okay, now, where the heck am I? Let's try that again. There we go. You should be looking at 15.4, I hope. Right. Can you see D here is a rectangular? Here's your density function. Can you imagine what the mass and that guy would look like?
So you would just put X bar and Y bar as a set of coordinates.
Yeah, and the brackets are already there. So you would say 15 sevens, comma 39. Well, 3/9 wouldn't be the right answer.
Okay.
1/3. Yeah.
Awesome. Thank you.
Right. When you're looking at this guy, although I haven't done it, can you see that there are 3 coordinate points? If you put them together, won't you make a triangle? Can you imagine then just finding the equation of the 2 lines? We did one that was like that. You got to do a bit more work. How do you get the equation of a line? Well, if you do 0 to this guy, it'll be y equals 1/2 x, and if you do 0 to this guy, what's that? It's just vertically upwards. Draw the thing and you'll see it. Here's 2 straight lines. We did that one. This one here, if you sketch it, can you imagine a parabola? They're looking like this, and then the x-axis going like that. So your region D is like the curved part of a hanger, right?
But because we have the y is equal to 0 for, it would be the
Right,
quadrant where the
y equals
parabola
0.
lays.
Sorry, the y equals 0 is just the x-axis.
Yeah.
Right. We did that guy. Oh, hint, use polar coordinates. Come on. If I see that, I shouldn't need a hint. Would you agree? If you see D described that way, it's polar. But okay, it's nice that they told us. Right, here's a picture. Find the center of mass. Okay, so darn it, what am I going to do with that one? That's a good question. I'll put a little note to self. Let's jump straight to, there's 3 more questions, but they're basically, here's a shape, here's a shape, here's a shape, right? So you're probably going to get non-rectangular in all 3 of those. So let's get these 2 guys out the way, and then with a bit of luck, I'll just be able to squeeze in 7. Because these are not difficult. Let's show you why. In my opinion, anyway, they're not difficult. Let's see if I can prove it to you. The formula for getting the total charge on a piece of metal, a laminar D, is sigma xy dA, where sigma xy is the charge density function. If you replaced sigma xy with rho of xy, wouldn't you be getting the mass? Although it's not a mass you're getting a total charge. So all you need to do is tell me who the guy is. So in question 11, the guy is made up from this fella, and the charge density function, as they call it, is that guy. So if you want to find the total charge, won't you do the integral from x equals 2 to x equals 5, the integral from y equals 0 to y equals 2 of the density function? We'll call it a density function, but it's density charge function, and do a dy dx. Would you agree that that's a pretty straightforward rectangular double integral? And you just do it in whatever order you prefer. If you're doing question 12, the region is described as this guy, and they should have called it sigma. But in fact, I think they did a typo. They called it rho. The good news is it makes no difference. Would you agree that if you're doing the entire disk, right, that it will be theta equals 0 to 2 pi, and r goes from 0 to 2? Agreed. The density function is this ugly mess, goes in here. And then you'll finish with an r, dr, d theta, right? So this bit here, just these two guys here, in polar form, what does 7x squared plus 7y squared look like?
7r squared.
Agreed? Now, won't 7x be 7r cos theta? And won't 7y be 7r sin theta? And from 0 to 2 pi, from 0 to 2, distribute the whole darn thing out. What do you get? You get 7r squared cos theta, 7r squared sin theta, and 7r cubed, a dr, a d theta, right? And you can't really separate them, unfortunately, because the powers of r are different. I guess you could pull out a 7 if you felt like it, but I'm not sure how much benefit you get in doing that. And ... Would you be comfortable about finishing that off now? Quite a long question, but doable. Let's... Perfect timing, I got 5 minutes, so I really zoomed by those two, but if you think about that, isn't it just the same process as finding the mass? They're just calling it the total charge, but mathematically, it's just a double integral of a density function. So let's get this fella, question 7. There is an A here, there's an A here, little right angle triangle thing going on. The density function is described as proportional, so that's k, to the square of the distances. Now, if it was proportional to the distance, wouldn't it be k square root of x squared plus y squared? But it's proportional to the square of the distances, so that's the density function. Now, this region here is D. I need to know the equation of this line. Now, normally you have numbers to work with, but that doesn't mean I can't do it. I just have an A to work with. What's the slope of this line?
-1, right?
Correct. Yep. And doesn't it pass the y-intercept at A? So couldn't I just say A take away 1x? That's the equation of that line. Are you cool with that shortcut way of getting the equation of the line? If you don't like that, find the slope and then do that fella. And maybe pick this point here as your x1, y1. And after a few minutes, you will still get that. Now I need to describe D. Can I do it vertically? Can I do it horizontally? Would you agree both are doable? And so, being a lazy kind of person, I'll do vertical. That means x will go from 0 to A. And y, well, y will start here, which is 0, and finish here, which is that guy. So far, so good. So let's get the mass then. The mass is the double integral of D of the density function, dA. In this case, 0 to A, 0 to A minus x. of this fella, dx dy. So that's going to be...
Wouldn't it be dy dx?
Thank you. Would be dy dx. Yeah. And if you do this fella with respect to y, oh, do you know that k? Can I just kick the k outside and that way we can forget about it now? So I just need to focus on this. It's going to be x squared y plus 1/3 y cubed evaluated at 0 and a minus x. That's going to be x squared a minus x plus 1/3 a minus x cubed. Oh, take away a whole load of nothings. And now we're getting to the point where I'm going to have to stop. What I would need to do next is distribute all of this. So I would end up with an ax squared, a negative x cubed, a 1/3 a cubed, a take away an ax squared, a plus an a squared x, and a subtract a 1/3 x cubed, and you can check that later to see if I did that right. And anything I can combine, I would do so. These cancel out, which is something. And this guy gets you negative 4/3 x cubed. And this guy don't do anything, so there. Now, when I integrate with respect to x, plug in x equals 0, plug in x equals a, and I'll get some, I don't know what I'll get. I'll get some messy answer, but it'll be the answer. And that's just the mass. Won't I then have to find x bar and y bar? So a lot of work in that question. A lot of work. But a really cool question. My gut feeling is because of all this symmetry, that the answer is going to be in the centroid of the triangle, which is basically what you get when you join a corner to the midpoint of the other two sides. I would bet a bottom dollar that that's the location. Don't know where that is in this particular example, but it is half of a square. So that would be on the diagonal of the square. So it would be on the y equals x. Oh, I will make a prediction. X bar and y bar will be the same. So when you finish doing this question, I am telling you right now, just because of the symmetry of everything, that the x bar and the y bar would be the same. That doesn't seem that unreasonable when you look at the shape. Don't know anything more about it, except that I'm pretty sure it's in the centroid of that triangle. And it won't have any k's in it. X bar and y bar will not have any k's in it. Okay, we got a few moments left. Well, we don't, but if you can bear with me. Test is on Monday. Test is the usual 8 till 10. You have until 10:30 to put it online. You'll do a copy with Adobe Scan or whatever you've got. Pretty much do everything you've done in test 1. Same rules. Does anybody know what test 1 is going to contain? What sections?
15.1 through 15.4.
Right, nice and easy. 15.1 to 15.4. And that's what your homework is going to be for this Sunday as well. Now, although there are only 4 sections, just based on what we did in this section, can you imagine there's a fair amount of time going to be involved in some of these questions, right? And for that reason, there'll be fewer questions, right? Because they take so much time. I haven't made the thing yet, so I can't tell you yet. When you go to Canvas, I will have probably by Saturday afternoon, late Saturday if I'm busy doing other things, how many questions are going to be. But I can tell you right now, there won't be 8, which would be 2 per section. There probably won't be 1. So somewhere between 5, 6 would be my guess right now. Guaranteed a question from each section, right? And it'll be chronological, right? So the first question you get is 15.1. You know, those questions are pretty easy because it's just rectangular. So you don't expect to spend a lot of time on them. So bear that in mind. But one of these guys, centenary mass fellas, can take forever. Unless I gave you a total charge one, which would then only involve one double integral. Any questions about the test? Say hi while you're thinking if you haven't already. Are we that good? You just know what's going to happen? You feel comfortable about what you're going to do and when you're going to do it? Then I'll hang about if there's any questions after class. Feel free to stay behind and ask. Otherwise, good luck. See you Monday for the test.
Thank you, Professor.
You're welcome.
So
Yes.
I finished the homework problem, but I have a question about this one. Can I share my screen real quick?
Let's do it. Okay.
All right. So it is question 10 about finding the volume of the given solid inside both the cylinder x squared plus y squared equals 9 and the ellipsoid given.
Yeah.
And I figured it out, but originally my answer was wrong. And then I had a hunch and I doubled it because I knew that there was volume above the above and below, I guess.
Yeah. And it was symmetric, so therefore the same volume.
Yeah. So
yeah. Which is why doing a graph of it is very helpful.
Yeah. Is there a way that I could account for that in the integral without just doubling it at the end? Or is there, and how should I have, I mean, I tried it the first time and then I looked at it and doubled it, but like, should there have been any hints there that I saw that led me to just double it right away?
Not so much the doubling, but there's a guy above and a guy below. And the hint is in the 4x squared plus 4y squared plus z squared piece. You see that equation there?
Yeah.
When you have to arrange that, you have to write it down as z equals, right? Because it's going to be a boundary on the z values. And when you see that z squared, doesn't that generate a plus, which is the above curve?
Oh,
and the
yeah.
negative,
So
which is the
it
below
would
curve.
do the square root. Okay, that makes sense. That it
so
has.
in this case, it's probably going to be, for the kinds of questions you're going to see at least, it's going to be symmetric.
Okay. Yeah, that would make sense that some would go above and some would go below due to the square root. Okay, thank you.
Oh, that was a very short question then.
Yeah.
Right, but the moral of that story, although I don't do it, and that's only for time issues, is plug the bloody thing into Desmos because it can give you some insight into what's going on. Very often it's helpful because you then can visualize the intersection as well. And you'll say, oh, it's a circle. And now I need to imagine what that circle would look like on the ground. And that way you get the D that you're looking for. I'm looking at this one right now. What did the thing look like? What was D?
The D was actually just that cylinder. So they sort of gave me the domain ready.
Oh, so it's just a circle of radius 3. Which
Yeah.
kind of makes sense, because if you rotate that shape so that I'm looking at it from above, if you could do that. Right, bang on. Can you see that circle?
I'm gonna tilt it just a little. Yeah, it made sense, and I had a false start, and then I kind of figured that out.
Right.
Was a good problem.
Yeah. Not all questions have to be handed to you on a plate. Sometimes you got to think about it.
Yeah. All right. See you
I'm
on
wondering,
Monday.
yeah, if you were looking at a shape like that, a volume like that, what would that really be? It'd be like a bead.
It's like a toilet paper tube with stuff sticking out both ends.
Okay, well, everyone sees things depending on their experiences. Okay, I didn't see that, but I guess that's true. I was thinking more that it was some kind of bead where they filled in the thing in some way. I don't know.
I don't know if that shape specifically has a name. It's sort of a mixture of cylinder and
Ellipsoid.
yeah.
Yeah. There are all sorts of names that I never bothered to remember to do with what 3D surfaces are called, but they're typically only for pure surfaces, right? Not a mixture of two interacting with each other.
Yeah.
So I'm pretty sure it doesn't have a name, at least none that I am aware of. Okay, if that is us, that's good. Brooke, Anna, do you have questions?
I do. It's over how to set up number 13 and number 15 and 15.2.
15.2. Let's find out where 15.2. Oops, I'm not in 15.2. I'm going to have to go out and in to find it, and I won't take go. Oh, I will, because it always logs me up. Yep, and it logged me up. That's annoying. Do you get the same issue that if you aren't doing anything on WebAssign for
Yeah, it
10
says
minutes,
stay
whatever?
logged in, and gives you a countdown from 10, and if you don't click it in time, yeah.
Yeah. Well, I know why they're doing that. It's to save students pretending that they're spending hours on WebAssign when what they did is load it up and go and watch a movie.
It's just difficult when I do a problem and then I try to go input the information and then it's like, well, you're timed out. I'm like, dang it.
What? Yeah. In the lower level classes, that's not an issue. But in some of the bigger ones, like the ones we've done here, you could spend 20 minutes on a question. And that might be more than it allows you to. Okay, I'm in. What section again was it?
15.2, number 13 was my first one, and number 15 was the second.
Right, so I've got a view opened up here. Oh. Okay.
I'm just thinking, I don't know how to do, like, I was having problems setting up the D with the, like, for the boundaries of X and Y.
Is it Z? Yeah, does it look like Z equals 5xy and a triangle with vertices? Is that the one? No?
No.
It's one with Z equals x squared plus y squared plus 1 and some information?
Yes.
Right, okay. So let's see. I'll close this window and open this one. Right, so though you got a guy that looks like this, right? Is basically your function. And then the region that you're interested in is described by quite a lot of things. Right, so let's put them together. If you do x equals 0, it's the y-axis. If you do y equals 0, it's the x-axis. That has no great effect. And x plus y equals 5 is this line here. So here is the region D. Did you figure out that's what they were talking about? I've lost you, Anna. Anna? Hi.
I'm still here, but it's not my question.
Yeah.
Yes, I'm still here.
Oh, okay.
So.
I have a triangle. Did you generate this triangle?
Yes.
Okay, so now we need to set up D, which is what your issue was. Just make sure that right now you could do vertical or horizontal. It doesn't matter. If I can do a vertical and it doesn't matter, I do. Just it makes my life easier. So it's going to go from 0 to here, which is 5. So X is going to go 0 to 5. And then Y is going to go from the bottom of the rectangle, which is 0. And the top is the straight line. And if I rearrange the equation of the straight line, it becomes that guy.
You get 5 minus X.
And that's this.
Okay.
That's
so I did
setup.
set it up right for my...
Oh, you just want to make sure it was
I was
right.
making sure because I had the X plus Y is equal to, the number, and I was putting it in Desmos, and I was like, okay, this makes sense, but I didn't know.
Huh? Well,
with
now
the
you did.
X plus Y.
What
And
was
then
the other one? 17?
It was number 13.
Oh,
and it
13.
It's another 1 plus X squared Y squared. It's X squared plus Y squared.
So yeah, the Z part really doesn't matter as for D. That is going to be the guy that goes here.
Yeah, and then D was X is equal to Y squared and X is equal to 4. Were my limits.
Right, if you put X equals Y squared, you will get this guy. If you put X equals 4, you will get this guy. So this is the region we're interested in. Now, in this question, vertical's no good because I'm going from the curve to the same curve. Bad idea. Horizontal is going to work. Okay?
Yeah.
Horizontal. Right. So D is going to be, well, let's see. I need to know some data points here. I need to know where here and here is. Right. Well, if X is 4, you can, Desmos will tell you, but that's -2 and 2. Right. So I know that Y goes from -2 to 2. And I now have here to here. This is what the X's are doing, right? So you imagine what's the X like at here and what's the X like at here. At here, it's a fixed value. Yes. At here, it's that guy. And that's you got D.
Okay. So it'd be Y squared is less than or equal to X, which is less than or equal to 4 for its range. Okay. All right. Thank you.
You're welcome. Okay, who's next? Brooke or Travis? Who's got a question?
I don't have any more questions.